Hello, everybody, and welcome to Let's Practice. This is practice number 1 in the series of quadratic equations with two variables. Welcome back. For you who've been here in our past series and in the introduction, I present to you our first practice. So now we're going to take it slow and see what we are doing each of our steps. Okay, because we already introduced the main concept, the new concept. But we're going to use the old concepts right now in detail to see exactly what we're doing. So at first, we're going to use the graphic calculator to expect what we are doing. Later, in practice number 2, we're going to do it without the graphic calculator. Okay? And later, the homework also will be blind without any graphic calculator to guide us along the way. But I'm sure that we'll do just fine. So let's see what we have here. Here we have a function where we have an x squared. We have some kind of a mixing term of x and y, and we have a y squared. All right, we know that this is the curve one, and we have a straight line right there. So let's see. There is a straight line, y equal to x minus 2. Well, it's this one right here, right there. We have a positive slope. Great. And I'm noticing something. This thing is a classic substitution candidate because I can take this y right here. I can move it all the way instead of this y and instead of this y. Why I can do that? Because remember, the intersection points, the y must be equal because it's an intersection point. It's the same point for both functions. Great. All right. Let's do it. Let's place them right there. And we get this result. That's it, guys. We reach our goal. Get to a one variable equation, in singular. Great. We got it. Now it's all about algebra. So let's do the algebra. All right, let's open the parentheses. 5 times x equal to 5x squared. 5x times minus 2 is minus 10x. Awesome. Minus 4 times, before opening the parentheses, let's expand them. X squared is this. 2 times x times minus 2 is minus 4x. Great. And minus 2 squared is 4. All right, guys, all of that is equal to 12. Now, what I want you to do, take 2 minutes, okay? It could be more than 2 minutes. I cannot check you anyway. It could be more. If you take more than 2 minutes, it doesn't call, it's not a cheating. That's what I'm saying. Okay, take 2 minutes. I want you to get to a quadratic equation with a single factor of x squared, a single factor of x, and a single factor of a constant. Okay? Do that, and I'll see you in a minute. Good luck. All right, let's see if we got the same result. Okay, so we're going to open this up. Minus 4 times x squared, that's minus 4x squared. Minus 4 times minus 4x is 16x, and minus 4 times 4 is minus 16. Now let's add every similar term together. 3x x squared here, x squared here, x squared here, gonna give us 4x squared. Now let's minus 10x and 16x gonna give us 6x. Great. And we're gonna take the 12, move it to the other side, and we're gonna get minus 28. So that's what you got. I hope so. I hope so. If not, do it again. You're gonna do it. Don't worry. So, instead of just plugging it into the quadratic formula, let's use the discriminant first. Okay. Let's see how many results should we expect. So, as a reminder, if the discriminant, this term right here, is bigger than 0, we should expect 2 results. 2 solutions. If it's equal to 0, we should expect 1. And if it's smaller than 0, we should expect No result, no intersection points. All right, so I plugged 6 right here in the B, minus 4 times A, which is 4, and times C, which is minus 28. All right, doing a little math, and we get a positive term. Now, let's plug it into the quadratic formula. We put this discriminant right here inside the root, which give us 22. All right, so this is B. I remind you this is minus B, and this is 2 times A. Okay, just like we see here. All right, so minus 6 plus 22 give us 16 over 8, which is 2. Minus 6 minus 22 give us minus 28 over 8, which is minus 7 over 2. All right, so we have our 2x coordinates for the intersection points. Great. Now let's plug them into the y. We're going to take this equation right here. We're going to plug 2 over here. We get the first one is 0, which is this one. And then we're going to take the second one. We're going to plug it inside, and we're going to get the second y coordinate. All right. How's that for a first exercise in our first practice? Quite cool, I think. All right. Let's do another one. All right. Here we're going to do another one. And this time I'm not showing you the graph. And I want us to use caution. Why? Because look, we have x in the denominator here and y in the denominator, which means that x and y cannot be 0 because a number divided by 0 is meaningless, undefined. We cannot have that. We can see that also right here. If x or y will be 0, then we're going to have 0 equal to 8, which is nonsense. All right, so what's our goal? Our goal is to reach a one variable equation, okay? Probably a quadratic equation. So let's see how we do it. What are we going to do? This is a prime example for a substitution, right? X is not equal to 0, y is also, so x, y is not equal to 0. So let's multiply both sides of this equation by xy. The factor xy, the number xy. Okay, so when we do that, we get this, xy times this, xy times this, and x times xy times this. Now, this x and this x can cancel each other out. This y and this y can cancel each other out. And here nothing cancels. We're going to leave it as is, and we're going to get this result. Awesome. Now, let's use our imagination a little bit, our creativity. We have an xy here, and we have a y here, right? You know how I like to start with an x only, right? So let's do it. I can take this xy, which is also appear here, and instead of writing xy, I can plug in an 8. And that's what I got. And I can take this y, so let's isolate the y right here by dividing by x, and we're going to get y equal to 8 over x. So let's plug it in. All right. So very quickly, we reach our goal of a single variable equation that would turn up to be a quadratic equation. So to get this into a quadratic equation form, let's multiply everything by x. Because I want to get rid of this x in the denominator. So after doing the 8 times 8, let's multiply by x. And I get this. This x is canceling out with this x. This thing going to give us x squared, and we're going to have 24x. Moving some things around, and I get there. I like to have, if it's possible, if it doesn't create any fractions, I really like to get a equal to 1 here. So let's divide by 2. And now I have a quadratic equation shape. I want you to take a minute. I want you to use whatever you want, a trinomial or the quadratic equation to solve for the x's here. Okay, so take a minute, good luck, and I see you in a minute. Okay, I believe you solved it. I do, I believe it. No, I know, I hope you did. You're going to benefit from it, trust me. Skill come with practice. All right, so what do we have here? We have A equal to 1, B equal to minus 12, and C equal to 32. So you can plug it into the quadratic equation and get the result you want. Of course, you're free to use the discriminant before to expect how many results you should expect. Now, I chose to use the trinomial. I love the trinomial. So what I'm asking in the trinomial is which two numbers, which when I add them, give me minus 12, and when I multiply them, give me 32. I do a little thinking, and I find that minus 8 and minus 4 meet this requirement. So these two numbers, minus 8, minus 4, are u1 and u2. Now let me rearrange it for the trinomial. Let me check it. X times x give me x squared, great. Minus 8 times minus 4 give me 32, great. And minus 8x plus minus 4x give me minus 12. I'm golden, great. So it's clear to see that we have two intersection points, x equal to 8 and x equal to 4. I'm going to use this formula right here. I'm going to plug the x's into here, and I'm going to get the two y's. And that's what I get. I get two intersection points. See? One here and one here. It's hard to see, so let's zoom in a little bit. Okay, we zoomed in. Now you can see that we have two distinct intersection points. Awesome, awesome. That's why I like the graphic calculator. It's so confirming that we did a good job. So it's great. We're happy with ourselves. All right, so now we are summarizing what we did in practice 1. Remember, the goal is to get to a single variable equation, even if the variable has the power of 2. Okay? Even, I'm describing it as a horrible thing. It's not. It's a good thing. It's mean more intersection points. Now, after you get a single variable equation, just solve. Solve as a quadratic equation. All right? After getting our first solutions, we need to think. Could there be more solution? Meaning, did we meet some kind of a plus-minus term on the way that split our path into two solution paths that we need to consider? We need to remember that. Now, let's talk about the homework. Here I have two exercises, okay? This set and this set. First, I want you to go to this site right here. I want you to make a drawing. Okay, it's a very simple to use site. It's a good tool. And I want you to make the drawing first. See the drawing, see what you should expect, and then I want you to solve. And these are the final results. After you do that, I'm going to meet you in practice number 2, where I'm not going to show you the graphs at all, and the homework will be blind also. You mean you're going to solve, and then you're going to make the drawing. But this is practice number 2. So I see you there, and thank you very much. See you later, guys.